One lab technique that's commonly done is collection of gases over water. A gas burette, or substitute piece of glassware such as the collection flask in this figure, is completely filled with water, then placed with the open end down in a beaker of water, which creates enough pressure to hold the water in the vessel. Tubing connects a closed reaction container to the collection container filled with water. Gases produced during the reaction travel through the tubing and into the gas burette, where it rises to the closed top end because it is less dense than the water, and as it does so, it displaces the water. The volume of gas produced can be measured by the volume of water displaced from the gas burette. Along with the gas that's being collected from the reaction, there's also some water vapor above the surface of the water. Some particles at the surface of the water have enough energy to escape into the gas phase, so there's always a little bit of water vapor above any sample of liquid water. We can express this as an equation. P total, the total gas pressure inside the burette, is equal to Ph2O, the vapor pressure of water, plus P gas, pressure of the gas collected from the reaction. As long as the water level in the gas burette is the same as the water level in the surrounding beaker, the total gas pressure inside the gas burette is the same as the atmospheric pressure on the outside of the burette, which can be measured with a barometer or looked up on weather.com. We could write this as an equation. P total, total pressure inside the burette, equals P ATM, atmospheric pressure outside the burette. To find the vapor pressure of water, we generally look it up in a table or apply the graph that's on this slide. What we notice is that vapor pressure goes up as the temperature goes up, but because it's not linear, it's generally easiest to just look up the value in a table. We would find a value that corresponds to the temperature at which we are collecting the gas. Here's an example of some calculations that go along with collecting a gas over water. We have 0.200 liters of argon gas being collected over water at a temperature of 26 degrees Celsius and a pressure of 750 torr. We need to find the partial pressure of the argon that we're collecting. We know that the total pressure is going to equal the pressure of the argon plus the vapor pressure of water. We could rearrange that to solve for the pressure of the argon. So pressure of the argon is equal to total pressure minus the vapor pressure of water. The total pressure is given to us in this problem as 750 torr. The vapor pressure of water you would have to look up in a table or on that graph. At 26 degrees Celsius, the corresponding pressure value for the vapor pressure of water is 25.2 torr. We can take our 750 torr of total pressure and subtract our 25.2 torr, which is the vapor pressure of the water, and that gives us 725 torr as the pressure of the argon. As you use equations like this one, the units must all be the same as each other. You can't mix units. So you have to do it all in torr, all in atmospheres, all in kilopascals, etc. Those units have to be consistent.